Good evening, student. Today I will discuss about mobility of charge carrier and also discuss about relation between drift velocity and electric current. Okay. Before I start about this one, I have discussed before topic. Before topic means what? That is drift velocity. You know drift velocity? Drift velocity is the velocity with which free electrons are get drifted toward the positive terminal of battery. Is it clear to all? So, here we know the formula of drift velocity Vd equal to, this is the vector. Velocity is a vector quantity, so we choose a vector. So, Vd vector equal to minus E by m into tau average. Okay. And another definition is here, that is Vd equal to Ev by ml into tau average. This is the two formulas which are related to drift velocity. First one is minus E by m into tau, and another formula is Ev by ml into tau. So here from above formula we know that the drift velocity is directly proportional to voltage across the conductor. At that time, that E means charge of electron remains constant, mass of electron remains constant. At a particular given temperature, this substance like a conductor which is present, that's why the relaxation time becomes constant. At that case, we represent a substance. The substance behaves as a conductor whose length also constant. Okay. While we considering potential difference, at that time E, M, L, tau remains constant. Clear? Whenever we consider again that Vd which is directly proportional to 1 by L, that means at that time the potential difference across the two ends of the conductor remains constant, charge of electron remains constant, mass of electron remains constant, as well as relaxation time remains constant, because that given substance like a conductor which lies at a particular given constant temperature. Clear? So that relaxation time becomes constant. You have to think that if we increase the temperature, then what will happen? That relaxation time. Okay. So here, if we increase the temperature above the room temperature or thermal temperature, then you know that inside the conductor there are many number of electrons are there. They becomes free and they moves randomly with zigzag motion. If we increase the temperature, then there is a collision in between them is very fastly, so that the relaxation time decreases. Means what? This is the electron, this is the electron that moves with certain velocity and it covers certain time, okay, for a particular room temperature. If you increase the temperature, then the electron becomes more energetic, so they collide very fastly, so that the relaxation time decreases. Due to decrease of relaxation time, its drift velocity decreases. That's why at a particular given temperature, relaxation time remains constant. Otherwise, it decreases while you increase the temperature, so that the drift velocity also decreases. Is it clear? So, this is all about drift velocity. Okay. Now, I will discuss about mobility of charge carriers. So, what do you mean by mobility of charge carriers? Here, what do you mean by mobility? Mobility means, in generally, it is the ability to move. What? Mobility means, ame general bhasha kahiba, it is the ability to move. Jahar saksham achi se kon kari pariba, move kari pariba, taku kahiba mobility. So, in generally, mobility means ability to move. Is it clear? जदि आम साधारण भाषा कहबा मोबिलिटी माने कोन एबिलिटी टू मूव. क्लियर? जदि आमे ताको आमे इलेक्ट्रिकल भाषा रे कहबा दैट मींस इलेक्ट्रिकल mobility is defined as the ability to move the charge carrier. Okay, that charge carrier means if the charge carrier becomes as a electron or it becomes as a positively charged carrier, like as a whole. Okay, under the influence of electric field, under the influence of electric field. So what done by electrical mobility? Electrical mobility is defined as the ability to move the charge carrier under the influence of electric field. Electric field ro under re ame jodi gote charge carrier को movement करे परिबा ताकू कहिबा electrical mobility. Is it clear? So from above consideration we know drift velocity whose formula Vd equal to what? Minus E by M E into tau. So this is the formula, minus E by M into tau. So this is the velocity is a vector quantity, electric field also vector quantity. Okay. So pile मु बिफोर क्लास रे इस वेक्टर क्वांटिटी भूली जाईची दया करी तमे फार्मूला जगह वेक्टर क्वांटिटी दे दबो. क्लियर? वेक्टर डायरेक्शन दे दबो, वेक्टर चिन्ह दे दबो. ओके, सो drift velocity equal to minus E by M into tau, और हमें भी लिखि परिबा what E V by ml into tau. Clear? So this is the two definition, two formulas which are related to drift velocity. Okay, how it can be possible? That means E equal to V by L is here. So E is the negative gradient of potential. That's why if you put the value minus V by L, then E minus minus cancel out. So E V by ml into tau is here. Clear? So here at constant, if we assume, okay, if we assume at constant temperature, then relaxation time becomes relaxation time becomes what? Constant. Clear? If we assume at constant temperature, then relaxation time becomes constant. So here in above formula, if you assume, that means drift velocity Vd vector equal to minus E by M into tau, that is electric field is here. So that here in that case E is also constant, that means charge of electron constant, tau is the relaxation time, that also constant, and that depends upon thermal temperature, so that it becomes constant. So here that becomes right here. Okay, and mass of charge particle, that means electron becomes constant. So that means charge of electron kete? Charge of electron what? That means 1.6 in 10 to the power minus 19 coulomb. Mass of electron what? That is 9.1 in 10 to the power minus 31 kg. Clear? So that remains constant, as well as tau remains constant, because tau becomes constant. How? because thermal temperature remains constant. At that case, so all the term which are remains constant. That's why Vd equal to constant into electric field. Okay, Vd equal to constant into electric field. That constant represented as a by the symbol mu. That is known as mu. So mu means mobility of charge carrier. What? So mu represents here mu represents mobility of charge. Mobility of charge. Whether that charge may be a positive or it may be a negative. Clear? So from above consideration, that mu also contain another definition. So mu equal to drift velocity per unit electric field. Okay. So from above formula, we can say that the mobility of charge carrier is the ratio of drift velocity per unit electric field. Okay. So here we write. Please note it. After that, I will write. Therefore, from that equation, okay, mobility of charge carrier is the ratio between drift velocity and electric field. Clear? So from above formula, we define a definition. That definition represents mobility of charge carrier is the ratio between drift velocity and electric field. Clear? So here we put that mu equal to what? Mu equal to drift velocity means what? That means minus E tau by m is here, and electric field also is here. So this is the definition of drift velocity per unit electric field. So electric field cancel out. So mu equal to minus E tau by m is here. In another way, you can define that mobility. Okay. This is the representation. So how mobility becomes vary? If the relaxation time becomes decreases or increases, then mobility becomes changes. That mobility of free charge carrier becomes changes. How? If we increase the temperature, then relaxation time decreases. Due to decrease of relaxation time, the drift velocity of free electron becomes decreases. Okay, that's why the movement of charge carrier also decreases. So that mobility also decreases. Okay. Now, here that is for electron case. For hole or positive charge, mu h equal to E tau by m. That is for negative charge and that is for positive charge. Here minus E represents charge of electron. Okay, and here that E represents charge of hole. Okay, charge of hole. It becomes positive, it becomes negative. So from above two formula, here while the charge becomes positive or it becomes negative, in that case mobility always positive. That means mobility always positive while that charge may be positive or may be negative. Therefore mobility always positive in nature, because nature, when the charge may be positive or negative. Clear? And also that mobility of charge carrier depends upon nature of the material. What? Nature of the material. Why? Because the charge of electron or hole remains constant, mass of electron or hole remains constant. At a particular given temperature, the relaxation time becomes constant. That's why we have assumed a substance, that substance may be a conductor. Whatever it may be a conductor, then it depends upon the nature. That mobility always depends upon the nature of the material. Clear? Because all this region, all these quantities are remains constant. That's why mobility depends upon nature of the material. Okay. Now I'll define the SI unit of mobility. Okay. Please note it. Unit of mobility. What is the unit of mobility? You know, mobility equal to drift velocity per unit electric field. Okay, mobility means drift velocity per unit electric field. Drift velocity means what? Meter per second. Electric field means what? You know, आमु जति जना नै आमे कोन करिबा force equal to Q into E. Force equal to Q into E. That implies E equal to force per unit charge. So that force means its unit is Newton and charge whose unit is Coulomb. So if you put the value, put the unit in that given electric field, then here we put Newton per Coulomb is 0. That means what? Meter Coulomb Newton per -1 second per -1. So this is the unit of mobility. Okay, meter Coulomb Newton per -1 second per -1. Okay, Newton power -1 second power -1. What is the dimension? You know dimension. Mu equal to what? Drift velocity. Velocity whose unit equal to what? Velocity means whose dimension is m1, m0, l1, t minus 1. This is the dimension of velocity. Electric field, how to calculate electric field? Energy. Sorry, electric field means what? That means E equal to V by L. Okay. So, or Newton per Coulomb. So, Newton, whose unit, whose dimension represent as Newton means m1, l1, t minus 2. How to calculate Newton? That means force equal to mass into acceleration. Mass means m1, acceleration means l1, t minus 2. So its value is L1 into T minus 2 and this value is M1. So M1 L1 T minus 2. So this is the dimensional formula of what? Force. That means Newton. Okay. And second thing is, so this is the formula of what? That is the formula of force. Clear? So, and if you divide, that is the Coulomb. Coulomb means whose unit is Coulomb? That is charge Q equal to Coulomb. Q equal to what? I into T. So I means what? That is ampere. Into time means what? Second. Or ampere power 1, T to power 1 is here. Clear? So we will divide that value like as A1, T1. So here what will happen? Good काम करो. Here m0 L1 t minus 1 is here, and this one m1 L1 t minus 2, and this is denominator 1 is here, so it is going to numerator, so this value is minus 3. A to power minus 1 is here. Clear? So mu equal to what? This is the value of mu. Mu equal to. So mu equal to what? So m to power what? M to power minus 1, L1 cancel out, t to power minus 3 which is going to numerator, then its value is t to power 2. Thank you. Upru gale kon hala? T to power 3 minus 7 gale kon hala? T to power 2 and a to power 1. Okay, that means m minus 1 L0 t2 A1. So this is the dimension of mobility. This is the dimension of mobility. So m minus 1 L0 t to power 2 a to power 1. Okay, please note it. So this is the mobility of free charge, equal to m minus 1 L0 t to power 2 a to power 1. So pile eta kichh no, eta mu levi nathili hala apne ki dao ya, please note it. Then I will discuss about relation between electric current and depth velocity after erasing this one. Clear? Please note it very quickly. Now I will discuss about relation between electric current and drift velocity. Clear? So what is the relation between electric current and drift velocity? So play, this is the very important relation, okay, while you solve the long question. Clear? So what do you mean by relation between electric current and drift velocity? As you know that this is the conductor, this is the conductor is here, you know, already I have discussed that conductor which is connected to a battery, that is the positive terminal, and this is the negative terminal, and that battery which is connected to that given conductor by through a wire. Okay, so that becomes plus, that becomes minus, so that while that terminal becomes plus, that's why it becomes plus, and that becomes minus. So there is a external electric field is applied due to high to low potential. Okay, we know that electric field moves always from higher potential to lower potential. Here that is a conductor whose length is L. Area of cross section, this is the area of cross section, it is given by A. Okay, area of cross section is given by A. Here inside the conductor there are many number of free electrons are there. These are the free electrons. Okay, clear? This is the free electrons. What? Free electrons. Free electrons. Clear? Clear? Now let us take a conductor of length L and area of cross section what? A. Clear? Area of cross section is A. Here inside the conductor there are many number of there are n number of, that is, if you represent many not is there, that is n number, that is capital N, that is there are n number of free electrons are there. Clear? There are n number of free electrons are there. N means, so in a given conductor, that means the conductor has certain volume. Inside the volume there are n number of electrons are there. Clear? Now if we assume small n gives electron density. What is the electron density? जदि आमे कोन करिबा, ए कंडक्टर को स्मॉल पीस रे जदि आमे भांगिबा, सपोज दिस इज द कंडक्टर, हियर this is the conductor, it has some area and this has some length. This is the conductor, it has some length, that conductor has length, and this is the area cross section. So it creates a volume. Inside the volume there are many number of free electrons are there, that many number contain n numbers. Okay, that is represented as n. If we segment that, if we assume that conductor becomes continuously segment, okay, so that in that part how many number of electrons are present in a particular given volume, that also that piece of conductor contain area cross section and it has some length, so they contain volume. So number of electron present per unit volume, which is denoted as electron density. So n gives electron density or number of electron per unit volume. Okay, therefore the number of electron, that is n number of electron present inside the conductor equal to the small piece रे केते number electron अच्छिंदी per unit volume, that is given by n. Clear? Okay, n means what? N means what? Number of electron per unit volume, okay, into ये जो कंडक्टर टा केते लेंथ नहीं की अच्छी, एते बड़ लेंथ नहीं की अच्छी, आर एरिया क्रॉस सेक्शन दिस वन इनटू व्हाट, हम जो स्मॉल पीस को जदि मिसेबा ये कोन होची गिवन टोटल कंडक्टर भाबे रिप्रेजेंट होची, तो आर भी वॉल्यूम अछि ना नहीं, तेनो गोटे सेगमेंट रो वॉल्यूम काढिबा इनटू टोटल सेगमेंट रो वॉल्यूम को जदि हमें गुणी दबा तार्थ इनटू वॉल्यूम ऑफ कंडक्टर, ताहाले हम कोन पाई परिबा, नंबर ऑफ इलेक्ट्रॉन प्रेजेंट इनसाइड द कंडक्टर पाई परिबा. सो n equal to what? n equal to number of electron per unit volume. ताहातो ए पीस रे, स्मॉल पीस रे जदि नंबर ऑफ इलेक्ट्रॉन अछि पर यूनिट वॉल्यूम रे, ए स्मॉल वॉल्यूम पे जति की इलेक्ट्रॉन रहिला इनटू ए कंडक्टर टा केते आर भी वॉल्यूम अछि ना नै, इनटू ए टोटल कंडक्टर जदि रो वॉल्यूम को हम जदि गुणिबा का सहित स्मॉल वॉल्यूम थिबा कंडक्टर आ ता भीतर थिबा इलेक्ट्रॉन सहित, ताहाले हम कोन पाई परिबा, ए जो टोटल कंडक्टर रे केते अमाउंट रो इलेक्ट्रॉन अछि ता पाई परिबा. So number of electron per unit volume into volume of the conductor. So number of electron per unit volume means what? Electron density. So that is given by n equal to capital N equal to small n into volume of conductor. Clear? Now equal to n into volume of conductor means what? Volume means area into length. So that conductor has some area and it occupied some length. So here we write area into length. Clear? So this is the equation number 1. Is it clear? Is it clear to all? Please note it. Is it clear to all? Please note it. Now, here from above diagram, that conductor which is connected by a battery, so that battery in order to flow the continuously and steadily the charge inside the conductor, so it provides an electric current. Therefore, the total current flow, therefore the total current flow through the conductor equal to what? That means I equal to what? I equal to what? Q by T. That means total amount of charge which are flowing through the conductor per unit time. That is called total current flowing through that given circuit. Clear? So I equal to Q by T. We know charge, total charge equal to what? We know the formula, charge equal to N into E. N means number of electron into charge of electrons. So N into E. N. Clear? Okay. So if you put the value in that given equation, then what will happen? Then, okay, that is equation 1 and that is equation 2 and that is equation 3. We put the value in equation 2, then I equal to Q means N into E divided by T. N means number of electron inside the conductor into charge of electron divided by time. So already we know that the value of N from equation 1 we get. আমি কোড পাইছে আমি n র ভ্যালু কোড পাইছে ইকুয়েশন 1 র পাইছে n র ভ্যালু কেতে প্লে NaL. So I equal to what? N means what? Small n into A into L E by T. Is it clear? Okay. LNaL E by T. Clear? Now, so while we connect a battery to that given conductor so that it supply energy to that given conductor, that's why the electron becomes energetic. They becomes move from one end of the conductor to other end of the conductor. Suppose electrons are moving in the direction, oppositely holes are moving in the direction, so that in a complete circuit the current moves in a continuous path. Okay, that's why due to only possible for potential. এটা কোডରୁ সম্ভব হৈ পারছে পোটেনশিয়াল যোগ সম্ভব হৈ পারছে। তার্থ এই ইলেক্ট্রনটা মুভ করুচি, তার্থ সে কোন দউচি কারেন্ট কো প্রোভাইড করুচি। সো ইলেক্ট্রনটা যদি এই পাথ কো যদি ট্রাভেল কলা, তাহলে এ কোন কলা কিছু ডিসটেন্স ট্রাভেল কলা, তো কিছু টাইম নেলা, তার কোন সৃষ্টি হলা ভেলোসিটি সৃষ্টি হলা। সো ভেলোসিটি ইকুয়াল টু কোন what? Distance by time. Clear? Distance by time. So please note it. After that I will erase that thing, then we'll solve the relation between electric current and due to velocity. Please note it. So here what will happen? I equal to NaL E by T. So we know the electron moves from one end to other end one end to other end, so that it cover a length that is L in a particular time, t. Okay, therefore it acquire a velocity known as drift velocity. So Vd equal to, or velocity, in general velocity it can be represented as a drift velocity. Velocity equal to distance means length of the conductor, divided by, or if you assume length of conductor can be represented as L divided by time. Okay. So therefore the drift velocity of electron, which is equal to, it passes from one end to other end of the conductor, so that it covers certain length L for a given time, that is t. So if you put that value, if we put the value in given equation, that is I equal to NEA L by T. Here L by T represent as V. That implies I equal to NEA VD. So this is the relation between current and drift velocity. This is the relation between current and drift velocity. So current, which is directly proportional to drift velocity when NEA remains constant. Okay. So when electric current directly proportional to drift velocity, at that time number of electron per unit volume, that is called electron density, remains constant, charge of electron remains constant, and area cross section remains constant, then current flow through the given conductor which is directly proportional to drift velocity. Clear? So this is the required expression of relation between electric current as well as electric current and drift velocity. So there are two topics I have discussed. The two topics are called, one is mobility of charge carrier and second one is relation between electric current and drift velocity. If any doubt, then ask me. Okay. Please like, share my channel. Okay. Thank you to all. Bye bye.